From the pendulum-like swing of a bowler's arm to the exact location that the ball strikes the 10 pins, bowling is a game that involves a lot of physics. When trying to knock down pins, a bowler has to take a lot of things into consideration, like where to stand, what the lane conditions are, what type of ball to use, and even how to throw the ball. For now though, let's start by talking a little bit about the game and its history. The game itself can be dated back all the way to 3200 BC in ancient Egypt. It's also been quite popular in the Roman Empire and in Victorian England. Bowling was brought to America with the colonists, although there were plenty of different ways to play it, like 9-pin games. And it was only on September 9th, 1895 that the American Bowling Congress was formed and established a standardized game with rules. Here's a fun fact. In 1841, Connecticut banned the 9-pin game because it was related to gambling. The game has a few important features: lanes, balls, boards, pins, and shoes. Lanes are where the ball rolls down. Balls are, well, balls. Pins are what you knock down. Boards are where the bowler stands, and shoes are what prevents the bowler from slipping and falling. Lanes are uniformly 18 meters long, with 10 pins in a triangular formation at the end and gutters on the sides. Balls, originally made out of hard wood known as lignum vitae, have urethane shells with a dense polyester core infused with either barium sulfate or calcium carbonate to lower the ball's inertia. Pins are coated with plastic, which increases their bounciness, and their shape gives them a low center of gravity, which makes them more stable. Each bowler, depending on how they throw the ball, will have a starting position and will generally move 4 steps forward before releasing the ball. This creates a positive horizontal force that will help push the ball forward into the lane and onto the pins. During the first step, the bowler pushes the ball in front of them and then begins to swing it back, creating a pendulum, giving the ball potential energy when it reaches its maximum height. The best position to let go of the ball is when the ball is moving parallel to the lanes and has most kinetic energy. The moment the bowler lets go of the ball, it will have 2 forces acting on it: gravity and the push of the bowler. This is where things get a little bit complicated. Lanes aren't constant. Sometimes they are really oily, other times really dry. Usually though, lanes are a mixture of oily and dry and typically follow patterns. The most commonly used pattern is oily in the middle of the lane and dry near the gutters. But the more professional a bowler is, the harder the patterns will be. The more oil a lane is coated with, the less friction the ball and lane system has, which is both a good thing and a bad thing. You see, the most efficient way to land a strike is to hit the pocket in a 30-degree angle, located between the head pin and pin 3 for righties, or the head pin and pin 2 for lefties. If you hit the head pin directly, you'll more likely than not end up with a split. To get to that 30-degree angle, the ball needs to hook, and for that, it needs friction. The more friction a ball has, the more it hooks, but the less friction it has, the faster it goes. Lane conditions have a huge influence on where the ball goes, and the bowler has 2 ways to adjust: moving a few boards to the left or right, or changing their ball. To get the ball to move more to the left, a bowler has to move however many boards necessary to the right. That way, the ball will move closer to the drier portion of the lane and hook more. To get the ball to move more to the right, a bowler needs to move an amount of boards to the left, getting their ball closer to the oilier portion of the lane and hook less. If the bowler decides to change balls, they have to decide on which ball is more appropriate for the lane condition. Normally, house balls, or rather plastic balls, have a normal spherical core in the ball's center and generally move in a straight line, although sometimes they can hook a little bit due to friction. Professional bowlers tend to use these to knock down the 10-pin. However, for normal throws, reactive balls are used. They are made for specific lane conditions since they have a modified center. The polyester core could have modified shapes or be shifted around to change the center of mass and increase or decrease the ball's hook. The different kinds of balls can be used for different kinds of pins, like the above-mentioned plastic ball for the 10-pin, or a more reactive ball for the 7-pin. The more professional a bowler is, the more balls they are likely to have, since most tournaments have many different lane conditions and skill shots. When the ball finally hits the pins, the heavy ball collides with the pins, causing a transfer of energy. This elastic collision is chaotic because not only are the pins being hit by the ball, but also by each other, since momentum is conserved. The chaos will continue until all of the pins have fallen, disappeared, or run out of kinetic energy. During all of this, some energy will be transformed into sound, creating a very loud noise. Now that we know the concepts, let's look at the math. The ball will start off with two forces acting on it while it falls on the ground. Eventually, when it lands, normal force will balance out the gravity, as Newton's third law says, so that the only forces moving the ball are the bowler's push and friction. The sum of all vertical forces will end up being 0, and the sum of all horizontal forces will be the bowler's push and friction. Since the ball is rolling down the 18-meter-long lane, it will have an angular velocity that will change directions due to the friction between the ball and the lane, causing it to hook. It will begin rolling with an angular velocity as well as a linear velocity, but because the angular velocity doesn't match linear velocity in the beginning, the ball will first slide along the lane, and friction will stop it from sliding, allowing it to start rolling. Finally, the ball will hit the pins, creating a series of elastic collisions. There is no potential energy, so there will only be kinetic energy in the system. The total energy of the system will be the sum of all of the kinetic energy in the collisions, or simply the kinetic energy of the ball pre-collision. Bowling is purely physics. A series of calculations could easily result in a strike. In fact, scientists have actually created a robot that does these calculations and performs splendidly well, imitating professionals and actually scoring strikes.